you had that intercept form. Well, actually, let's pull this up. No, this is 5. So I'm pretty sure the other ones that I gave you were the 19 through 24, right? So just for Yeah, I'm just doing the easy stuff. Because it's always as clean. Take a second. Try this one out. I gave you another kind of an easy one. Because you have a 0 for an x. And remember, that's whenever you have 0 for x, that means it's going to be your y-intercept. Remember how we always talk about, why do you use 0 for x? You use 0 for the other ones. Ha! Never mind. This one is a little bit tougher. I never liked you to begin with, but that's okay. At least you're so, negative. I think that is your x1. Okay. Now, remember, guys, your generic form is going to be ax squared plus bx plus c is y. I'm just writing it with the y on the other side because it's normal how we look at equations when we have systems like this. So you're going to write it out 3 times. You've got your negative 2 squared, so I'm going to get 4a minus 2b plus c is 0. All right. I get 1a minus b plus c is 2. Then I get 9a plus 3b plus c is 0. All right with that? Okay. Now, when you get stuck to something like this, you have to try to figure out, all right, what's an easy way to use systems of equations to eliminate a value? Or, you don't want to give up, but let me ask you this. If you're going to solve an equation, what would you do to solve for x? Okay, why do you divide? What is division in regards to multiplication? It's opposite, but we also call it math. It's called the, you're right with that. It's called the inverse operation. You guys remember that? Inverse? Okay. The inverse operations. Inverse operations are doing the opposite, like you were saying. In this case, it's a reciprocal. What's the inverse of adding? What's the inverse of squaring? Okay, so the idea of using inverses is how you would solve equations. Now, what if I told you that there was a way that you could just put this in your calculator? Now, have you guys ever heard of what's called a Have you guys ever heard of guys? Have you ever heard of a thing called a matrix? Yeah, it is kind of that. Something that holds something. Mathematical. I don't know about that. Now, what a matrix is, in our case here, what a matrix does is that it's a way of grouping numbers together. Okay? It's a way of taking awful-looking things and grouping them so that they're easier to work with. So what we do is we're going to create what's called a coefficient matrix. Now, a coefficient matrix is nothing more than all the coefficients on the left-hand side of the equation, because 0, 2, and 0 would be a solution. Right? So if I write out the symbols for matrices is this. It's the giant brackets. Okay? And I put in my coefficients, 4, negative 2, 1. 1, negative 1, 1, 9, 3, 1. Okay. What's that? Yes. Yes. Because I know that these things get awful and nasty, but yet there is a really simple way to solve it. We'll see. We'll see. Not there yet. Okay. So let me take this to another side so I have a little bit more space. We'll come back to that here in a second. Okay. Now, basically, what we need to solve for are going to be our A, B's, and C's. Okay. So what happens is we're going to create A, B, C. Now, what's there is a coefficient matrix times your variable matrix to equal solution matrix. Okay. That's for the 0, 2, and 0. Those were the ones, correct, for the y's, I believe? Now, what happens here is, just a second ago, I asked you guys what the inverse operation of multiplying was, and you told me it was division, kind of like you said, reciprocal. Now, if you look at your calculator, maybe, I gotta restart my calculator. Now, hold on. I want to show you guys a button that you might not know what it means. It's not the matrix button. Okay. Now, real fast, like we said earlier, the inverse of multiplying is division. Well, and that's reciprocal. Now, do you know, or do you remember what this meant? 1 over x. Very good. That meant 1 over x. So what would be, which is a reciprocal, isn't it? Isn't that the inverse? The inverse of 2 is 1 over 2. The inverse of x is 1 over x. So if you look on your calculator, isn't there a button? Everybody see that? Now, we know that 2 to the negative 1 would be a half. It just so happens to just put it by. But that's what it does. It takes the inverse of that. Now, going back to this whole idea of a matrix, to undo multiplying, I'd have to do the inverse of that, right? So that basically tells me that I can do A, sorry, my A looks like a 9. A, B, C is going to equal, what was it? 4, negative 2, 1, 1, negative 1, 1, 9, 3, and 1. Inverse times. Now, there are ways to create and solve for inverses on your calculator, or on, not a calculator, but also by hand. For example, if you look at that next to the W flag back there, there's that by hand written out determinants and of matrices that I did a few years ago. Well, I didn't do it, some kid did it. But what we do now is that we don't worry about doing that by hand. There's a button. So here's where you have to be careful. There is a way of entering in matrices, and I think it was alpha zoom. Yes. Alpha zoom is the shortcut key to creating a matrix. Now, what happens here is that matrices are written by rows and columns. Rows are what you could row your boat on across. Columns are what hold things up. All right, you'd be surprised. People get a flip. It makes a lot of sense. If you have a row, if you're rowing a boat, you want to go left to right. Because if you're rowing a boat and you're going up and down, you're dead. Because you fell off the waterfall and you are now dead. So, oops. All right, so what we're going to do is we create a 3 by 3 matrix. Now what's nice is that right away, when you hit enter, oh, I'm sorry, I have to go down to OK. You're going to get a visual right away of what it should look like. If it doesn't look like what you think it should look like, that means you flip-flopped your rows. It's kind of hard to screw it with a 3 by 3, but the 3 rows, 1 column, you'll see right away that you do tend to screw that up. So what we do here is we put in our coefficients. Be very careful when you put coefficients into a calculator. It is so easy to screw it up. All right. Always use the negative button, not the minus button for your negatives. Okay. So I believe it was what 4, -2, 1, 4, -2. Hit the right arrow to move over. What was the next one? 1, -1, 1. 9, 3, 1. Thank you. Now to that, I have to put it to the -1 power. It's okay. It's okay. Hold on. You haven't done the last part then. Now we have to multiply that times the solution power. Make another matrix. Alpha zoom. This one was a, you don't have the multiplication sign in there. You know, because it automatically, when they're put together like that, it's automatically by their multiple. So this one's going to be 3 rows, because you row your boat, 1 column. Was it 0, 2, 0? Yeah. Okay. Now, with any luck, if you hit enter, those answers are now your A, B, and C. Hey, now watch this. Math, enter, enter. Whoa. It'll switch it over to fractions for you. Math, enter, enter. Yep. So this tells me now that my values are so that means A was -1/2, B was 1/2, C was 3, I believe. Was that what it was? Yes. So then my equation then winds up being y equals -1/2 x squared plus 1/2 x plus 3. And that's the equation that contains those points. It's not a difficult thing to do, but you have to be extraordinarily cautious to do that. Now, here's the deal. I could give you these problems to do with or without that calculator. If I give you the problem to do with the calculator, that means you won't know what C is. But I can give you the problem to do without a calculator if I give you the C. You know, does that make sense? I think that's fair because you're just solving like a 2x2 system, which isn't all that bad. But going to a 3x3 system with some of these things giving fractional answers, I mean, you can see it on your face, right? Like, you're like, yeah, I know. All right. So try this one real quick. See how you do. Matrices are great for this stuff. And again,